Team Antikythera checking in for the last time. Keith Finch here. To start, demo day was a success. It was fun. I mean, we got to meet with the wonderful Dr. Kaziki. Abdullah stopped by. And we even had a PhD student stop by who's actually currently doing research with wireless communications and SDRs. So, the market, right? I suppose that our project would be geared towards. We stopped by, we did our demonstration, we had some pretty in-depth discussions as far as what our, project could do, and that actually ended up leading to some further communications with that student and Dr. Uesha. So who's to say what will happen there? But going forward here, we're going to pass off all of our work, video logs, progress reports, user manual to Dr. Uesha, so he and his research students can actually use this for their research and to continue to develop it. I mean, these developments include further enhancements to the GUI, some more improvements for the D2D communication features, and just kind of touching up and adding whatever else they want to use for their research. So, all in all, it was a success. We all had great fun. And up next is Anwar.
Thank you, Keith. Anwar here. We started out our project with the intention of implementing a 5G cellular system using SDR devices with a focus on low latency, low error rate, and device-to-device communication. Soon we realized that we would not be able to meet this objective if we did not put in place first a structure that would tie in all these SDR nodes. And therefore we had to pivot into creating a federated framework for SDR devices. The framework revolves around a distributed architecture that encompasses a discovery and pruning processes, a command and query protocol, and an internal file transfer mechanism. In addition, we built several GUI controllers to provide the users with a single entry point to control all the nodes on the network and remotely modify their properties, making them transmit and/or receive. We also made the framework generic so it can be adapted to a wide gamut of nodes ranging from transceivers to IoT devices. The framework API is entirely implemented in Python and is extensively multi-threaded throughout, relying on sockets for low-level network communication. It is also highly parameterized via satellite configuration files and consists of about 4,000 lines of Python code together with 500 lines of MATLAB scripts that are used solely to calculate the bit error rate. We were able to meet all the deadlines and implement all the intended specs. The framework is fully functional and was successfully demoed at ASU's Capstone Project Showcase. And now Zach will present one of the GUIs. Thank you.
Thank you, Anwar. So with the large success of our project, we were also able to incorporate a second graphical user interface, which was independent of the actual software-defined radio hardware. And this allowed us to achieve this success. Without the ability to independently develop this graphical user interface, which was streamlined for the user and provided an ease of use for the user, we wouldn't be delivering the product that we are to the ASU Research Lab and to anyone who will further work on this project. So now I'm going to pass it on to Vincent to close this out.
Thanks, team. Vincent here for our final video of our Senior Design Lab at Arizona State University. To close out our Senior Design Lab, we will be providing the demonstrated software architecture with an associated user manual and final report that will provide additional context to allow follow-on teams and additional users to use this software architecture and grow upon this baseline that Team Antikythera has provided. We thoroughly enjoyed this project, and we're very excited to see what it becomes. Thank you.